Welcome everyone to build your own content fact checker. I'm Zhenwei from the Cerebras team.
I'm Khushi from the Parallel team.
Today with Cerebras and Parallel, we're building a content fact checker. Drop in any article or URL and it extracts the content, identifies every claim, searches for evidence, and returns a final verdict. True, false, or uncertain, with clickable links to every source.
Here's what you'll walk away with today. First, free API credits for both Cerebras and Parallel, so you can keep building after this workshop. Second, a complete quick start guide to build your own content fact checker. And finally, your very own content fact checker.
This is the content fact checker we will build today. Clean on the surface, but powered by serious intelligence underneath. And by the end of the workshop, you'll know how to build it yourself. Before we dive into the code, let's talk about what makes this possible, Cerebras and Parallel, and how they enable full article analysis in just seconds.
Parallel's Search and Extract API makes real-time content extraction across the web possible for AI. Instead of scraping pages or stitching together search results yourself, you call the Parallel API and get structured results and source content back in real time.
Once that content is retrieved, the model needs to analyze and reason over it, and that's where Cerebras comes in. The LLM is run on Cerebras hardware, the wafer scale engine, or WSE3, which is the massive AI chip that delivers the fastest inference in the world for up to 15 times faster than GPU providers. Now, let's get everyone set up to build your own content fact checker. Scan the QR code or use the link below to open our Google Code Lab notebook. It has all the code we'll be using today.
Let's start with the essentials. Install packages and set environment. In your Colab notebook, you'll see we're installing Parallel Web and Cerebras Cloud SDK. Run that first cell to get everything installed. While that's running, let's go ahead and grab our API keys. You'll need a Cerebras API key and a Parallel API key. Both API keys are available in the Colab notebook.
While you're installing these packages and getting your API keys, let's talk about the problem we're solving with the content fact checker. So first, how is fact checking traditionally done? It starts with reading a long-form article and identifying a claim that raises an eyebrow. You're not sure if it's true or not. Where do you look for answers? You have to do a lot of things manually. Search it on Google, ask ChatGPT, dig through books, maybe talk to an expert, and clicking between tabs the whole time and taking notes as you go. Then you would sift through your notes, connect the dots, and check through each claim against each other. Needless to say, it's a pretty manual and iterative process.
So what if we brought in AI? What does it mean to power fact-checking with AI? Let's look at how the same fact-checking workflow can be streamlined with an AI-powered system. Instead of going through articles to highlight each claim you find questionable, you can just paste in the URL or paste the entire text. Your choice. With a URL, the system pulls the page and extracts the readable content using Parallel's Extract API. It strips out menus, ads, and scripts, returning clean text ready for analysis. Next, Cerebras comes in. Once Parallel retrieves the content, any LLM can be run on Cerebras to produce the entire document in seconds, identifying every claim worth verifying. Instead of manually scanning paragraph by paragraph, the model converts raw text into a structured list of checkable statements in a single pass. Parallel's Search API then researches the web and returns relevant sources and excerpts for every claim. Then, the Cerebras LLM compares the evidence to the claim and classifies the claim as verified, false, or unsure. Each claim is returned with that final classification, along with a link to the original or primary sources used to reach that conclusion. Altogether, the system automates the full workflow: claim extraction, web research, and source-backed verification in one pass. The more specific your prompt, such as restricting sources to archive, the more precise and aligned the results will be.
Thanks, Khushi, for breaking that down. In general, AI-powered fact-checking is perfect for any use cases that involves auditing long-form content at scale, verifying claims in seconds, cross-checking sources, and returning cited results automatically. Okay, let's get back to building. At this point, hopefully you've installed your packages and set up the right environment as the first step. In step 2, let's look at the small helper function we use to talk to the Cerebras LLM. Call Cerebras Chat is just a wrapper around the Cerebras Chat API. Instead of repeating the same API call everywhere in our code, we put it in one place and reuse it every time. This function takes two inputs: the system prompt, which defines how the model should behave, and the user prompt, which contains the task. We package the prompts into a message list, send them to Cerebras API, and return the models as response. So anytime the fact checker needs to extract claims, analyze sources, or classify results, it simply calls this function and gets a clean answer back.
Now, we connect our fact checker to the internet using Parallel's Search API. First, we define a retrieval objective. This tells Parallel what kind of sources we want: high quality, up-to-date, and preferably from authoritative domains like .gov.edu, major news, or official organizations. Then, we call parallel-client.beta.search. We pass in the claim as the query, set how many results we want, and request long excerpts so the model has enough context to reason over the evidence. Finally, we normalize the results into a clean schema, URL, title, publish date, and excerpts. That way, the rest of the pipeline always retrieves structured, predictable evidence. This function is our evidence fetcher. Give a claim, it searches the web, and returns the sources we need to verify it.
Then we want to organize and summarize the web results. We retrieve resources with search web claim, then pass them into build evidence context or results, which turns them into a clean evidence block with source IDs, titles, URLs, dates, and excerpts. Now, instead of raw web pages, the LLM receives a structured bundle of evidence ready for analysis.
In step 5, let's make the pipeline more reliable using strict schema validation and constrained decoding. We define a claims output pydantic model, which automatically generates a JSON schema. Then, we call the Cerebras API with strict equals true, so the model is required to return output that matches the schema exactly. That means no regex cleanup, no defensive parsing, and no fragile post-processing. We can safely call json.loads and trust the structure. The result is cleaner code, simpler error handling, and a pipeline that's easy to maintain. If we ever want to add fields, we just update the model class and the schema updates automatically.
Finally, we're on step 6, where everything comes together. We take a single claim and check it against real-world evidence. First, we define a fact check output schema that requires 3 things: a verdict or short explanations and the top supporting sources. The verdict is constrained to one of 3 values: true, false, or uncertain. Inside fact check single claim, we search the web using Parallel, gather a small sets of high-quality sources, and build a structured evidence context. We then send both the claim and the evidence to the Cerebras LLM with a strict JSON schema. Using constrained decoding, the model must return a structured verdict that matches our schema exactly. Because the structure is guaranteed, we can safely parse the response and return a clean, source-backed result or verdict. This function is the heart of the fact checker. Give it a claim, it retrieves evidence, and delivers a final judgment you can trust with cited sources. Looking ahead, this fact checker can be deployed as a hosted service, packaged in Docker, or exposed through an API gateway, then run on platforms like AWS or GCP. On the user side, you can meet people where they are with a browser extension, a lightweight web app, or even social media integrations for pre-posting checks.
And that's a wrap. You've just built a sophisticated fact checker system that combines the best of web search and AI analysis. You now understand how modern AI-powered search, analysis, and verdicts work under the hood.
Remember, you have free API credits for both Cerebras and Parallel, plus the complete code guide to keep experimenting. Now, go build some amazing, super fast search agents. And of course, feel free to tag us and share with us what you build at Cerebras and at P0 for Parallel Web Systems on Twitter. If you want to talk more ideas or have questions, let us know in the comments below.
Thanks so much for tuning in. We're excited to see what you build.